Hi, my name is Maribeth Lee, and I'm an Intel analyst at the Vertex project. In today's video, we're going to go through two different use cases for Synapse. The first one is going to be focused around a blog that I'm going to want to process as an analyst. And the second is going to be a little bit shorter. It's going to be focused around a malware investigation. So with our first use case, we'll pretend that I'm an analyst back in December 2020, and Mandiant, FireEye at the time, just came out with this blog where they're talking about a supply chain compromise that they identified. Now, as an analyst, it's my job to figure out what exactly they're talking about, if this is activity that's entirely new to me, or if it's something that might be related to something we've been tracking. I'll want to see if I can build out anything that they've provided, identify some additional indicators, maybe some additional threads of activity, and then I'll also want to be able to put together all my findings so that I can share it with my leadership and they can use it to help make an informed decision about what we're going to do, what this might mean for us or for clients if we have clients that we're protecting. So this is the blog that I'm going to be working with, and I'm going to be working within Synapse. Well, this is my Synapse instance. The first thing that I'm going to do is fork a view. Forking a view is going to give me a scratch space in which I can do my work. I'll still have visibility into all of the data and the annotations from all of our previous research and analysis that all lives in the underlying view. However, everything that I add when I'm within my forked view, so when I'm working on this investigation, everything from data to tags and things like that, those are all going to stay within my scratch space, within my forked view. So at the end of my investigation, I can go through, I can check all the changes that I've made, I can correct any errors that I might have made, and then I can go and I can merge that data down into our production layer to join the rest of the data that we have from our past research and analysis. So I'm going to name this MB OSINT just so I know what I'm working on. And so here I am in my forked view, my MB OSINT view. And from here, there's a lot of different ways that I can pull data into Synapse. Because I have that one blog that I really want to do a careful read on, I'm going to be using a tool that we have called Spotlight. And with Spotlight, I can either upload a file locally or I can provide the URL and Spotlight will go out and grab it for me. Either way, I'll end up with something like this where I have the blog on one side. I also have this downloaded to Synapse so that the bytes are stored within Synapse. In case it disappears from the internet or something, I can always download the copy from Synapse again so I can see it again. So I have the blog here. This is going to be modeled as a media news node. And then on this side, I have all the different indicators that Spotlight went and scraped out for me that it recognized. Typically, the indicators that's going to recognize are things like hash values, email addresses, FQDNs, IP addresses, URLs, things like that. For the sake of this demo, we went ahead and pre-processed things. So I also have things like file bases, crypto X509 cert nodes, file byte nodes, etc. So when I go through this within Spotlight, typically the first thing that I'll do is I'll go and populate the different properties on that media news node. So that's easier for me to recognize. So I'll go ahead and highlight the title and I'll set that as the title for that media news node. I can also maybe grab this first bullet point here and set that as a summary. So I'll go populate that there. And then I'll grab FireEye since that was the company at the time and set it as the publisher name. Now, as I go through, there's probably additional things besides what was automatically scraped out that I'll want to be able to capture. So for example, in their original post, they noted that UNC2452 was how they were identifying this activity. So I can always go and highlight that, go to create a node, and then set it as an OU name. Now that they've gone and done their update, I can also grab ABD29 and set that as an OU name as well. Both of those will show up here on this side. All of the nodes that are on this side are also going to be linked back to the media news node. So I have an easy way to see where they came from, what blog referenced these. And then I can go through and just read my blog. If there's anything else that I see and I want to be able to capture, like the name of the malware family, Sunburst, I can go ahead and create that as a software name. I'll go ahead and add that and I'll scroll through. I'll also be able to see some of the things that maybe Spotlight recognized and created for me or suggested for me. And I'll also be able to see any data that's kind of percolating up from that underlying production level. So using this URL as an example, this might be something that another colleague had previously created when they were reading some investigation or doing their own research or something like that. One of the things that I might note about this is that if I look at the details for this INET URL node on the side, it includes several different tags. We use tags for a couple different reasons within Synapse. For one, we use them as a way to keep track of assessments, both our own internal assessments and then third-party assessments. So as an example, the tags that I might be applying here would be things like rep FireEye Sunburst to note that this was reported by FireEye as associated with the Sunburst malware family, or rep FireEye UNC2452 to tie it to FireEye's assessment about that activity as being UNC2452. However, if this is something that's kind of percolating up through the production level, I might also see other tags like rep Palo Alto Solar Storm. And maybe that's something from a Palo Alto blog that my colleague was working on, where they noted that this URL is associated with what they're calling Solar Storm, just their name for the same set of activities. So tags can be a way to keep track of those third-party assessments, also our own assessments. And then we can also use tags like this VTX Story Nightwatch tag just as a way to kind of organize our data. So this VTX Story Nightwatch tag is an example of a tag that I'll be using throughout this investigation. I'll just be applying this to all the different nodes that I'm working with as a way to keep track of all that data. One of the things that you might also notice here is that there's a little bit of color coding going on. One of the tools that we have is a workspace tool, and it allows you to adjust your kind of analytic environment. And one of the things that I like to do is I like to assign colors to certain tags, just so if anything is reported with a third-party assessment, it will show up in kind of this gold. Anything that we've internally said as malicious or associated with a threat cluster that we track will show up in kind of this vibrant pink. Some other colors just as an easy way for me to recognize that that has a certain tag on it. So that's a little bit of what you'll see here. So I'll continue to read through the blog. I can kind of verify some of the things that I might be interested in pulling out. I can also go ahead and apply some tags. There's things that I want to be able to capture, either their assessments or our own assessments. And everything that I go and capture here is going to be created as a node, and it's going to be linked back to this media news node representing the blog, so I have an easy way to see where that data came from. Now, as I've gone through, and let's say that I've processed this entire blog, I can then go and I can lift this blog in the research tool. So we'll go and lift that media news node. And here I have this media news node that's representing the blog. I'll just scoot out this column a little bit so that we can see the publisher name in full. And I see the details on the side here, including the file bytes for the blog itself in case I need to download this again from Synapse, the title, the summary, the publisher name, everything like that. And then everything I pulled in from that blog is linked back to this. Now, I processed the blog itself, but one of the things that Mandiant noted, or FireEye at the time noted in the blog, was that they also had some additional indicators on a GitHub page. And those are things I'm going to also want to pull in. So this is what they have. They have two CSVs, one with hashes and another with network-based indicators. And I'm going to want to go and pull these in as well. Now, because these are CSVs, instead of using the Spotlight tool, I can use the ingest tool. And this is a really easy way to go and bring in structured data, especially if it's kind of a one-off ingest, like something that's in the CSV file, rather than a source that I'll continuously be trying to pull from. So this is an example of what that hashes file is going to look like. I get a preview of the contents here, the different hashes that they have for each file. They also have some file names, version, compile time, signing time, things like that. Down here, I have a little Storm script. Storm is the query language that we use within Synapse. And the Storm script is just telling Synapse how I want this data to be modeled. So I'm going to be creating a file bytes node and also some different hash nodes to capture those different hash values. Then I'm going to be applying my tags, that rep FireEye 2020-12-13 tag, and note that this was reported by FireEye on that date. My VTX Story Nightwatch tag as a way to keep track of this as part of my little investigation by keeping it tagged with that Nightwatch tag. And then I'm going to go and link it back to that media news node so that I know the source. So we can go ahead and run that, and it just completed. And then we'll do the same thing with the network-based indicators, so the second CSV that they had. And in this case, I'm creating INET DNS CNAME records, INET DNSA records, and then just like I did with the last CSV, I'm applying a rep FireEye tag and VTX Story Nightwatch tag, and then I'm linking them back to that same media news node. So we can go ahead and run that. And now that's ingested, and they're all linked back to that media news node. So from here, I can go and view those indicators by just exploring out to see everything that's connected to it. And everything that shows up in gold has that rep FireEye tag or that third-party tag highlighting. And from here, typically what I'd want to do is then go and query some additional data sources to see if there's additional information that I can pull in to try and investigate this activity further, see if I can kind of build out what FireEye provided and identify maybe some additional indicators or instances of activity or things like that, or tie it back to something that we might be tracking, things like that. The ways that I'm going to be doing that is using a tool that we have called PowerUps. And PowerUps there are connectors to third-party data sources, or if we have our own data source that we want to be able to query again and again. They also help to extend the functionality of Synapse. So we have a PowerUp connector for, say, YAR rules, so that we can run YAR rules internally within Synapse. The ones that I'm going to be using here are all going to be querying these third-party data sources. For example, Synapse Alien Vault will go pull in data from Alien Vault. I also have a Synapse Virus Total power-up that I'll be using to pull in data from Virus Total, things like that. Now, there's a couple different ways I can call these power-ups. Because I was bringing in a lot of data at once, I used some automation to just make that enrichment go a little bit more quickly. We support two different types of automation, cron jobs, which are those scheduled jobs, and then triggers, which are event-based. And I actually used a trigger for this specific project. And I'll show you which one I used. It's this one here. So this was the trigger that I went and I ran. It is called an enrich reported IOCs trigger because it runs every time I tag something with a rep tag. So every time I said that this was reported by FireEye as associated with Sunburst, or it was reported by FireEye as, on December 13th, 2020, something like that, it would kick off this trigger, which would run a macro that's just a container of storm code. My macro is called enrich. It's not particularly imaginative. And if we want to see that macro, we can actually go over to our macro tool over here. And this is the macro that I ran. So the macro is just a different storm code that's going to identify the form that I'm feeding to it. And it will pipe that against all of the different PowerUps commands that are capable of providing additional information for that form. So as an example, for an IPv4 address, it will pipe it against MaxMind to pull in geolocation data, Alien Vault, Census, Shodan, NetTools, Zetalytics, Virus Total, querying all our different data sources to pull in that data and model it for me. So using automation to run this means that it runs as soon as I apply that tag. So by the time I get here to go and take a look at these indicators that we have, I can just do things like I can select this FKDN, for example, and explore out, and I'll be able to see all of that data that was brought back from those other data sources. So as an example, I might take a look at the DNSA records. Maybe there's something here that is particularly interesting to me. I can go ahead and select that. Maybe let's pretend that this one is what I'm interested in. Maybe I want to see if there's any overlapping infrastructure that might be of interest that was hosted on the same IP address. I can go and pivot to it and see this IP address. We don't have a lot of information. At this point, I might want to do a more targeted enrichment. So maybe I can go and run MaxMind. I can see the updates that were immediately brought in. And then I might go and maybe run NetTools to see if there's any DNS data that was brought in. It looked like I didn't get any for this. So maybe I'll go and see if Alien Vault has anything and run that instead. And here I can see that Alien Vault does have some passive DNS data and it's pulling it in up here. I can see the changes that it's noting. And I can also just go and, for the sake of time, pause that so we can go and pivot out. And I can see that it made 445 different nodes that it brought back for me. So that's one way I can kind of use automation to do the big bulk ingest and then maybe do a more targeted enrichment as I kind of poke at a certain IOC and kind of go down that specific rabbit hole. So all of the data that we've looked at so far in the research tool, which is where I am now, has been through something that we call tabular mode, where I have the different tables. This is probably the way that I prefer to work the most as an analyst, just because I like how this data is visualized. I like being able to do things like sort and kind of change around what columns are where. For me, it's just an easier way to visualize the data that I'm working with. However, if you have different visualization preferences, or if you're doing a certain task that requires you to look at data a little bit differently, or you're working with another type of data that might be easier to view in another mode, there are different visualization modes that you can leverage. and we'll go and just walk through what those are. So rather than tabular, one of them that you might take a look at is force graph. And force graph is a really good way to be able to see how things are or are not connected in the graph. In this example here, I'm lifting all of the nodes that I have tagged with that rep FireEye 2020-12-13 tag. So this is all of the data that was pulled in from the blog and from those two CSVs. And here are all the nodes here. One of the things that kind of jumps out at me from this is that there's several different clusters where I can see that they're connected. If I'm curious about what a specific node is, I can select it and I'll see the details on the side. So this is the INA FQDN for website theme.com. However, there's also a lot of nodes that are just kind of floating out by themselves, like this file base name, where they're not connected to anything. And that's something that is a lot easier for me to see through force graph mode than I would be able to see through tabular. In contrast, if we take this image and we try to remember it, and then we go and we run everything that has the VTX Story Nightwatch tag. So this includes all of the data that I was bringing in through enrichment and kind of my additional research into the original activity in the blog. If we go ahead and lift all of these, the visualization changes. And so this is a lot more, everything here is connected. And so what that, why that is because when we went and reran those enrichments and we did our additional investigation into the things that FireEye released, we were able to connect a lot of the dots and then be able to show and understand for ourselves why FireEye said this activity was all related and part of one cluster. So when they're publishing their report, they're not able to include really like that level of evidence. It's hard to just have that all released at once. Because of sensitivity issues, it might also be something that they're not able to share every detail. But through our own research, we were able to kind of build out some of the missing pieces and be able to now see how everything looks like it's related and looks like it's tied together into one cohesive unit of activity. One of the ways that I'll also use force graph mode is if I'm doing my own research and I want to just check to see how different threat clusters that I'm building out look, if they're related or if they're kind of clustered and identified properly. So one example that I have is that there was a blog I was working on a while ago where they had reported activity that they said was part of the same cluster. And I was trying to build out that cluster, but ended up with two, and I wasn't able to really connect them yet. And I wanted to check to see if there's overlap that I just wasn't really seeing through tabular mode. And so one of the things that I did was I color-coded each cluster differently based on the tag. So I had T211 and T215 as my other cluster. I made one of them green and the other red. And then I went ahead and lifted them both in force graph mode just to see if that would be an easier way to see where there might be some connections between the two. So doing this, it shows me that there's one node that's actually connecting both clusters. When I go and click on that, I see that that's just a file MIME, which is not what I'd want to be using as evidence that something is related to another set of activity. So what I do here is go ahead and remove that node. It just removes it from the visual itself. So then it's a lot more easy for me to see that there's actually nothing that I have currently connecting these two. So in addition to seeing that I don't currently have any evidence that these are part of the same cluster, I also see that I have some cleanup that I need to do. For example, I have one cluster here, but then I have some nodes that are tagged, but are not actually connected. So it looks like this is a file bytes node, and I think this other one is also a file bytes node, but I don't have them connected back to the main part of the cluster, so I haven't made that cluster cohesive. So this is an example of something where I'd probably want to go and do some additional research and see if I'm able to identify and then tag that evidence showing that this is related to the rest of the T211 cluster. And if not, I'll want to go ahead and remove the tags from these. And that's just so if another analyst, or even if I come back later, I'll want to make sure that the evidence is there and that I'll understand why I said that this was all related. And if it's not, if I can't build out that evidence in the graph and reflect it, then I should go ahead and rethink that assessment and remove the tags there. So that's a way that I can use force graph mode just as a way to check my work there. In addition to force graph mode, we also have what we call stats mode. And we'll go and switch over to that. And for our example, we'll lift all of the file bytes nodes that we have that FireEye has reported as associated with APT1. And then we're going to specifically look at the ones that have compile times. So one of the things that stats mode will do for us is that when we lift this query, it will take the data and it will break it down into several different statistical projections for us. Some of the ones that are particularly interesting include this compile time breakdown over here, where it took the compile times and broke them down by days of the week. What jumps out at me looking at this is that Monday through Friday tended to be pretty busy in terms of when these files were compiled. Saturday and Sunday, it was a lot quieter. That might let me know that this is something that was happening on maybe a regular work week schedule, or at least a more consistent daily schedule rather than someone who's just compiling malware, on their free time. Maybe one day it's a Saturday or another day it's another day. This looks like a much more consistent kind of regular effort. I can remember this visual, and I can also switch this from days of the week to hours of the day and see that data broken down by hours. And here I can see where it was a lot of work was being done, things were busy. Suddenly there's a drop off, nothing was compiled. People started compiling things again. There's another drop off, some more work here, another drop off, a little bit of work here, and then it's fairly quiet. So one of the things that I might do is take this breakdown and juxtapose it with what we saw over the days of the week, and then see if I can find where in the world, what time zone this would make sense. If the days of the week activity that we saw suggested that this was maybe a regular work week effort, I might try and see what time zone this would match with, where this is reflective of a kind of a 9 to 5 schedule. That might also give me a hint at where these operators, or these developers rather, are working, or where they're based. If I wanted to see that breakdown a little bit differently, I can also see the compile times just over a longer time frame. So right now this is broken down by weeks, but if I wanted to make it a little less granular, I can change it to see the breakdown by month, or I can even go and set it to year. And then this shows me that it looks like the earliest compile time that we have for any one of these samples is one file that has a compile time for 2004. The bulk of the samples that we have within the Synapse instance are from 2009 through 2012. And then we have 2 files with 2013 compile times, and then that's the end of the data that we have available. So stats mode is kind of a fun way that we can lift data and then see all the different statistical projections broken down into different ways. So in addition to tabular, force graph, and stats mode, if you're working with any sort of geolocation data, you can use geospatial mode. And for this, we're going to be looking at a project that one of my colleagues had done. So my colleague was doing an investigation into a Russian cargo ship that had been sanctioned by the US back in 2014. And so he pulled some data for the ship just to kind of see what it was up to now and what it was doing. I believe this activity is from 2022, early 2022. And one of the things that he found was that the ship was going into a Russian port, a Russian terminal up here, and then it was traveling south. It was turning off its AIS data so that we couldn't see any of the location information for where it was. When it would reappear, it would then go back up north. One of the things that was interesting that the data provider included was the draft property for this ship. And we can actually see it here, this draft property, which is the keel depth of where the ship is sitting in the water at the time. And my colleague was able to see from this that when the ship was coming into the Russian port and then leaving and going south, it was sitting much lower in the water, suggesting that it was carrying cargo at that time. It would disappear, and when it would reappear again and we were able to track it again, it would be sitting much higher in the water, suggesting that at the time that it had turned off the AIS and that beaconing information, it had gone into port, made its delivery, and then now no longer had cargo and was going up to resupply. Based on that information, my colleague believed that the ship was probably trying to maybe hide where it was delivering or where it was going into port, or at least give itself some plausible deniability by shutting off the location information. He believes that the ship was probably going into Cyprus, somewhere over here, and that they were then kind of coming back online and going up again to that terminal to get more cargo for another delivery. So this is an example of something that is much easier to see in geospatial mode than it would be in tabular or force graph or stats mode or something like that. So those are the main visualization modes that we have. However, we're continuing to develop and build out other ones. An example of one of the newer modes that we're still working on is called tree graph mode. And this is a helpful mode to use if you're looking at any sort of hierarchical information. So as an example here, I have the US Secretary of State, and then I have everyone who directly reports to that position. I can also go and expand this out if I'm interested in a certain department and see what the reporting structure is for that department going down. So tree graph mode can be a really helpful way if you're looking to kind of see that hierarchical information. In addition to tree graph, another mode that we are introducing is timeline mode. And this can be a helpful way just to visualize different events that have occurred. This example that I have here is one of a investigative journalist who later found that his phones were compromised with Pegasus spyware. So I used timeline mode to be able to map out and visualize certain things, like when he released a report, when the official, it was a lot of Hungarian officials who were kind of came across really badly in these investigations. So I had the date that he released a report, kind of the response or the apology or the attempt to kind of recover from the Hungarian official, and then later down where the journalist identifies that his phones have been compromised, that he's been targeted with Pegasus spyware. So timeline mode can be a helpful way to be able to visualize that chain of events. Now, all the different visualization modes that I have here are things that I'm able to go and reflect in our internal reporting tool called Stories. So kind of going back to my original investigation into this supply chain compromise, that might be something where I put together a story that summarizes my findings so I can share it with my leadership. So this is an example of a story that I might put together. I'll go into preview mode here. I can include a title and summary there. I can include a picture if there's any sort of public announcement or a tweet that went out notifying people. And then what I like the most as an analyst is that I can ingest data directly from Synapse and put it in my story. So here I have different reports that are modeled as media news nodes that I've lifted here. I can also include things like text to kind of explain my findings. And then here I have some of my indicators of compromise. One of the things that I've struggled with in a lot of the past roles that I've had is that when it was time to do a report or it was time to share my findings, and especially in written prose, is I would have to take the data that I was working with out of whatever I was using for my research and analysis, and then go format it in Microsoft Word or whatever I was using to put the report together. If I was continuing to do any sort of research, I would be flipping back and forth, trying to make sure that whatever I have in my research and analysis tool is the same as what I have in my report, that my report reflects the most up-to-date findings. And if I was ever peer reviewing somebody else's work, it's kind of a pain to take their findings back out, put it in whatever your research and analysis tool is, and then kind of do your check of their research. Because this is embedded within Synapse, it's a lot easier for me to go and refresh the data to check that my queries are pulling the up-to-date information, things like that. So using the example of these domains that I have here, I can go back into edit mode. If I am changing the data at all and I want to make sure that everything here is updated, I can always go and refresh the nodes or refresh the query that I use to pull this data, and it will go and query Synapse again, put the results here. It's an easy way to make sure everything is up to date. Like everything else within Synapse, Stories is also intended to be collaborative. So if I have a colleague that I want to come in and peer review my report before I hand it off to whoever the audience is, I can always share the story with her. She can come in. If she's looking at this data and she wants to kind of check my research, or she's not entirely sure how I came to these conclusions, she can always copy the query that I had used for this and then go back over to the research tool and probably go back into tabular mode and then paste that query, and she'll be able to lift the same data. And from here, maybe she'll want to do some enrichment with those power-ups that we have, or else she can pivot out and check the additional information that we have just to see if there's evidence backing whatever my assessments are. She can also leave me a comment if she wants to note something for me. So as an example, if there's a general comment that she wants to leave, she can do that. If there's a certain issue that I have on a certain spot, she can leave a comment specifically for that part of the report. I can respond to comments. I can also resolve them. So this faded one is an example of something that I've resolved. And then when I'm ready, when I want to go and share my report, I have a couple different ways that I can do that. I can go over to my story settings and I can save it and give somebody else viewer permission so that they can come in and see it. Or if I'd like to give them a external copy, I can always go and export it as a PDF, and then they'll have a copy of that report to use. There are some additional things that we've kind of played around with stories to do. Like one of them is we've created story templates for common reports that we might want to be able to generate easily. One of the examples that we have is for a threat group report, where we basically use Storm for each of the sections to include a Storm query to lift certain indicators or targeting information or things like that. And then we can go up to the menu here and we can refresh all the element queries and basically populate the report for whatever threat group we want it to focus on. So there's lots of fun things that you can do with stories because it is embedded within Synapse. So from here, I've gone through and I've pulled in that blog that I was working on. I modeled it and I modeled the different indicators that I wanted to pull out. I tagged everything. We use the ingest tool to bring in those two CSVs and model that data, link everything back to that media news node. I used automation. I used that trigger to go and call those different power-ups to query those third-party data sources, pull information related to the indicators into Synapse and model it for me. And then I was exploring, I was pivoting around to view the different data that I had that came back, tagging some additional findings that were of interest. I was able to identify some of the connections between that data and show why FireEye said that this activity was all related or part of the same threat cluster. And then I put together a story with my findings that I can then go share with my leadership. At this point, I'm still within my forked view, within my scratch space here. If I'd like, I can go and see the changes that I've made just to double check, correct any errors that I might have. Otherwise, I can go ahead and I can merge this down into underlying view and it will join the rest of the data that we have from our previous research and analysis. So that concludes our first demo, our first use case that we have here. And we'll go ahead and switch over to our second use case. So our second use case that we have is a little bit shorter. It's more concise. This one will be focused around a malware investigation. For this, we'll pretend that I am supporting some colleagues who are doing an investigation into some suspicious activity on a client's network. One of my colleagues has asked for some help with some files that they'd found. So they created a JIRA ticket for me. There's 3 different hashes that they have here, and they want to know if these are related to malicious files, if they're part of anything that we know about, whether it's a malware family that we track ourselves or that we've read somebody else's report on, if it's associated with any sort of threat groups, either publicly reported or that we track ourselves. So this is where I will start my work, and we'll switch over to my Synapse instance. And just like I did with the last use case, I'm going to fork a view. This, in this case, is not only to give me a scratch space in which to do my work, but in the case that I'm working with client data that might be sensitive, having a forked view, I'm automatically going to be the only one with access to it. So I'll probably go ahead and also add my colleagues as well so that they can see this data. But otherwise, this forked view is basically going to serve as a kind of protective layer for me so that I can have that more sensitive client information in here. Just for this investigation, it will keep it private from anyone else who has access to our Synapse instance. At the end of my investigation, I can selectively merge down data that we're allowed to keep, but otherwise I can delete the view and it will get rid of the information that we're not allowed to retain. So we'll go ahead and create our forked view there. So here I am in my MB malware forked view. From this point, I'm going to want to be able to pull in that JIRA ticket with all of the details that I need to know for what I'm looking into. I switched over to text search mode, and I'm going to use that to actually lift that ticket. I think it's MDR 63. So the different power-ups that we used in the previous use case were all different third-party data providers. However, we also have additional power-ups, including a JIRA power-up, and that's how I actually got this ticket here, is that I can search for JIRA tickets from Synapse. I can pull them into my Synapse instance so that I don't have to do all this modeling. And I can also go and create JIRA tickets from Synapse as well. So here's the JIRA ticket that I have. I can pull out the details here so I can see all the different properties. We also have some tags here, just to note as organization that this is part of the MDR 2021-902 case. So I know that the case number for this. And we'll go ahead and explore out and see those files that were included in there and scraped out. So these are the files that I'm going to be working with. And we'll go ahead and just lift these by themselves so we don't have to look at that other information. Because I haven't done any sort of enrichment or anything, I don't really have any information about these so far. So I really just have the SHA-256 hashes and then the tag noting that they're part of that case. If I select them all and go and explore, I'll get back to the hash SHA-256 nodes. I can also see some earlier information that we have. It looks like at one point, these were found on certain hosts. These are the names. These are the paths that we've seen. And then I also see that ticket where they came from. But there's nothing like behavioral information or network communications or anything like that. So whereas I had used a trigger to go and run the enrichment for our previous use case, here I'm going to just use a node action and use that as a way to go and query all those different power-ups and pull in data, so that I can see what we know about these file bytes nodes from all those different sources. So some of the ones that we're going to be querying are things like AlienVault, if AlienVault has any data about these, virus total, both the file report, so the static information, all of the different A/B hits from those different A/B engines that run when you submit something to virus total. So we'll have that detection information here. Behavioral information, so any sort of execution data that we're able to get from virus total, and I think also from hybrid analysis. So we have different sandboxes that we'll be pulling data in from as well. I'll also be running things against YAR rules that we have within our Synapse instance, and we will cover one of the workflows that we have that's specifically designed to help manage YAR rules. And then we'll also be applying tags. So any of the assessments that were made by any of those resources, virus total, for example, or hybrid analysis, showing what they might have assessed about these files, we'll be able to see those as well. So my power-up made a lot of different, or my macro made a lot of different edits. We can see them up here, 24,000 edits on almost 5,000 nodes. Some of the edits you can see instantly, the things that were populated in these different properties. We can also see that the color coding changed on one of these. And this is, again, due to that workspaces tool. One of the things that I have within my workspace is a rep whitelisted color coding for this tag, so that anything that includes or a third party has reported as whitelisted, it will actually show up white, just as an easy way for me to recognize that. So we'll go ahead and start with this whitelisted file. So if I select this file, I can see the details on the side here. Besides all of those different properties, I can also see the tags that came in through from virus total and from hybrid analysis. It looks like hybrid analysis said that this is a whitelisted file. Virus total said it's a known distributor. They also said it's a trusted source. So we kind of get their assessments and we can go and take a look and see if there's additional information that helps to back that. So we'll go and explore out and see what we have here. And we'll take a look at the versioning information. It looks like this is something with the Microsoft Corporation copyright. So we can take a look at the different, if there's anything that looks like it was suspicious from a C2 or something like that. We can also take a look at the A/B scan information to see if there's any sort of results that came in through all those A/B engines that run through hybrid analysis or virus total. And it looks like we weren't able to get any signatures and no verdicts that say malicious for this file. So this might be something that we don't have to worry about. So for the sake of time, we can always say that based on what we saw, nothing really immediately jumped out. So we can go back to our original files and we'll take a look at the executable. So for this executable, taking a look at the details on the side here, looks like hybrid analysis says it's malicious. There's not that much else in terms of tags that we can see that they made assessments about. taking a look at some of the properties, one of them that might jump out to me is this PDB string. It's fairly unique. I can always pivot on this and see if we have anything else within our Synapse instance that has this exact same PDB string. So I can go ahead and click on it and pivot and lift any other file bytes nodes with that same string. So I get two results. The orange is my initial, and then the pink are two that we have some sort of internal assessment that's malicious or associated with the threat cluster. So we'll take a look at the first one. So this file bytes node, it looks like we came across it previously. So this is something that's percolating up from the underlying production level view. It's also data prior research and analysis that we're now re-encountering. So it looks like previously when we saw this, we said that it was part of a code family that we call Froyo. It's associated with malware that we call Froyo as well. It's also associated with a threat cluster that we refer to as Sundance. And then finally, it looks like NetScout reported this as what they call the Cobalt group. We take a look at that other file, it looks like we have the same tags here. Another thing that we could go ahead and do since we have this set up is be able to just kind of scan the different properties like the compile times. We know the PDB paths are the same since that's what we pivoted on. You can take a look at the import hash, things like that. The size, if there's other data here that we want to be able to compare to see similarities that might also be here in addition to the PDB path. So kind of coming across that data that was from our prior research and analysis can give me a little bit of a hint at what I might be looking at. However, we can also go back to our original files, and I can explore out from this file to see if there's additional data. So going and exploring out, some of the things that I might take a look at are things like if there's DNS requests, any sort of network traffic from this. This is kind of a funny looking domain here. So I might go and explore to see if there's more information I can pull in about that domain. So this is in pink, so it lets me know that this is something that we've previously made an assessment about. It looks like based on the tags that we said this was part of the Froyo malware family. It was part of the Sundance threat cluster. We also have a TTP tag, so this is evidence of a TTP that we're saying is masquerading, where they were designed this FQDN to masquerade as a resource of a legitimate bank. I can see in the little note that pops up there, I think that's a Romanian bank. And then this was also something that NetScout had reported as associated with what they're calling the Cobalt group. If I would like to, I can always pull in additional, maybe updated information here. If I want to pull in more recent DNS records or something like that. I can also go and pivot off of this to see some of the previous research that we have, like the other files that we saw that did DNS requests the same domain as well. If I want to see the DNSA information or things like that. But I can also stay focused and kind of go back to my file and look at the other data that we have that's available. So it looks like it communicates with a C2 that we associate with Sundance and Froyo malware. I can also take a look at the Yara match node that we have here. It looks like it matched on a rule that we call the Froyo backdoor. I can explore to see the rule itself, and I can always hover over it to see how it was written and what was designed to detect. However, there's also kind of another way that I like to be able to view and work with Yara rules, and that is through the Synapse Yara workflow. A lot of the different power-ups that we have will have accompanying workflows that just provide another way to kind of interact with that resource. So for the Synapse Yara workflow, this is what it will look like. Here's the Froyo backdoor. Here's how it's written. It has the color coding to kind of help with the formatting. The workflow here is a really good way to both create, test, and then manage all of your Yara rules. So here's an existing rule, but if I wanted to try and create another rule, I can always go fork a view. So I have a scratch space. I can write my rule, and then I can test it by running it against all the different files that we have where we have the bytes downloaded. So I would be able to see the rule up here. If I was truly organized, I would have the versioning information. I can also see on the matches tab kind of a history of the different detections. So it's a very helpful way to kind of manage all of your different Yara rules. So we know it hit against this rule for the Froyo backdoor. In addition to communicating with that C2, I can also take a look at some of the A/B hits that we have from VirusTotal and maybe hybrid analysis. So this one, in contrast to that whitelisted file we see, a lot of the signatures are things that they said it was malicious. there's kind of generic names here. So not really anything that is jumping out at me as a kind of a widely known public name. So maybe there isn't a public name for this type of malware, but it looks like the consensus is that this is something that's pretty malicious. And then if there's additional information that I'm interested in looking at, if there's any sort of execution data, I can go and I can take a look at those as well. Otherwise, I can go ahead and walk back and look at our last file. So the last file that we have is this MS Word document. It looks like hybrid analysis said it was malicious. From VirusTotal, it might contain some obfuscated macros based on their tags here. So we'll go ahead and explore to see what data we have. One of the things that I could do is check out some of the MIME information for this file. In this case, it doesn't look like there's anything here that's particularly revealing, but if there was a specific author name that I wanted to try and pivot on, or created times or something like that, to see if there's commonalities between this and other files that we had, that would be a way that I could go ahead and do it. We'll take a look at the YAR match that we have here. It looks like it matched on a rule that we call suspicious word document. Let's go and jump down to see some of the A/B scan results. So doing that, it looks like there's a bunch of different signatures that we see. So go sort this the other way. So there are a bunch of different signatures that it looks like the verdict is malicious for this. Again, it's kind of generic detections, though. They all mention that there's some sort of downloader. So we can try and see what this downloads. So we'll go take a look at the execution data that we have and see IT exec URL. So it looks like it tries to download a text file from this URL here. We can go and pivot to see the URL itself. And the pink again lets me know that this is something that we're encountering again, and we've previously said that this is malicious or tied to a threat cluster. And from the tag, we can see that this is that Sundance threat cluster that we're running into again. I can always go and pivot again from here, and we'll be able to see the FQDN. And then if we were able to download that info text file, we'll see it. It looks like we were not able to grab that text file since it's not showing up here. However, we can see the FQDN itself. It looks like we said that this was malicious, associated with that Sundance threat cluster. We're seeing that same masquerading TTP, where it's masquerading as a legitimate Microsoft domain. And then it looks like NetScout also said that this was what they're associating with the Cobalt group. And then I can also see some of the other activity that we had previously taken a look at, where I have another file that also tried to download the same text file. So based on what I've seen so far, I think I have enough information to go and tag my findings and then let my colleague know that I've investigated these. So for this document, we're going to go and note that this is something malicious. So we'll tag it with CNO-mal. I'll also note that this is associated with the Sundance threat cluster. And then I'll note that Sundance threat cluster own and apply those tags. The color coding immediately changes, and I can see the tags down here. I'll do the same thing for this executable, except I'm going to note that this is specifically part of the Froyo malware family, and apply that. And then the whitelisted file, we're just going to leave as tagged with whitelisted. There's nothing else that I saw that kind of gave me a more specific finding that I would want to capture as my own assessment. Now, if I was not familiar with either the Froyo malware family or the Sundance threat cluster, and I wanted to be able to get kind of a high-level overview of what we know about that malware family or that group, I could again go and use some of the workflows that we have, specifically the Vertex threat intel workflow. So this one is designed as a way to help us do any sort of threat research. So I can go and I can use the threat clusters to look up the Sundance threat cluster. I can see from the details that this is something also goes by the Cobalt group, which is the NetScout name. This is something that we track internally, so we're the reporter. And then I can go through the tabs here to be able to see what additional information we might know about this. So for example, we know that it uses the Froyo malware family. It looks like we have two different techniques that we've seen this cluster use, phishing and then masquerading, those domain masquerading. If there are vulnerabilities that we saw them use, we'd see it here. If there's any sort of activity that we've previously seen, like it looks like we have some phishing operations that we've seen here. If there's any compromises we know of, if there's campaigns, it looks like we have a phishing campaign against financial institutions. can also check targeting information. It looks like it's targeted organizations in Romania and Russia, specifically the finance and insurance industry. It looks like the goal is a financial goal, will obtain money. And then if there's any news reporting, I would see it there. So I can use that the threat intel workflow as a way to be able to get a high-level overview. If I was adding additional information, if there was another malware family I saw this cluster use or something like that, I could use this to help me walk through that modeling. In this case, I'm not adding any of those additional findings. And then if I want to do some more tactical information, I could always go and do something like lift the tag. So let's say that there is additional, now that I know what this group does, if I want to be able to provide more specific information that maybe my colleagues can use to kind of inform their investigation, I can go and lift those indicators here. Like if there's certain certs that we've seen this cluster use. I can also share emails since we know that this group engages in phishing. If there's samples of malware, I can always pass them that the YARA rules that we've seen. If there's FQDNs that we've seen as well, they can see if there's any additional traffic to these while they're doing their investigation. Much more tactical and detailed information I can share as well as kind of that overview from a high level of what we know about this cluster. So I've gone and I've done my research, I've tagged my findings. I've also taken a look to just get both a high level overview and then a more, I guess, tactical understanding of the resources that we've associated with this cluster. I can go back to that JIRA ticket and I can use my Synapse JIRA PowerUp to go ahead and resolve the ticket. That will let my colleague know that I've done my work. I can share my forked view, my scratch space with my colleagues so that they can come in. They'll be able to do the same thing that I did where they pivot out from the ticket. They'll be able to see the tags with my assessments that I've applied. They can use the threat intel workflow to get that high level overview of the cluster or the malware family if they'd like to take a look at that. And then they can also use the tags as a way to pull that more detailed information like the FQDN that they've used in the past or the email addresses that they've used in the past. Because this is a client investigation and depending on whatever our data privacy policies are, this might be a case where I go ahead and just leave my forked view as is until the end of their investigation. And then if I'm allowed to keep some information, I can selectively merge that data down into the production level. So it will join the rest of our research and analysis. However, if I'm not allowed to keep anything, I'll just go ahead and delete this view and delete the data in it. If I'm allowed to keep everything, I can always go and I can merge it all down. So I have several different options there for how I handle the data that's within this view when I'm done with this. So that concludes this video and the two use cases that we walked through. I hope that they're helpful and informative. If you have questions, please feel free to reach out to us. You can reach us on Slack or through email, and we'd be happy to try and answer anything that you might have.